All right, hey, hello, ladies and gentlemen. So today we are on day 8 of Unit 9. Okay, and our goal is that I can factor completely. Okay, I can factor completely. That is our objective today. So I'm going to start by talking kind of like what we did in class today. So here's the key for this. Always start with a GCF. Is there anything that you can take out? So kind of like what we did in class today. So as we look at, for example, like two quick examples, 16x plus 36. Okay, so is there anything that goes into both of those, 16 and 36? 4. So we're left with 4x plus 9. Okay, there's nothing more we can do there, so we're done with that problem. Okay, let's look. 9x squared plus 24x. Okay, anything that goes into both of those. Hopefully by now these are kind of coming to you. Okay, so 3 goes into 9, 3 also goes into 24, and an x goes into both of them. So we've got 3x, and we're left with 3x plus 24 divided by 3 is 8. So that's where we're starting. Okay, so we always look for that GCF and start there. Then look for like trinomials, okay, which we've been factoring. Look for trinomials, look for difference of squares, of perfect squares, I call them, perfect squares. Okay, so look for those things, and I'll just give you some examples to try. Sorry, I'm so stuffy. I'm still getting over my cold. Okay, so for example, and we're going to do these together, 28x squared minus 63. Okay, so first, is there a GCF that goes into 28 and 63? 7. So if we take out a 7, we're left with 4x squared minus 9. Okay, this is not a trinomial, but is it a difference of perfect squares? Yeah, we've got a difference of perfect squares there. So we've got 7 times, okay, what's the square root of 4? 2. What's the square root of x squared? X. What's the square root of 9? 3. Okay, and then we have 2x plus 3. Okay, looking at our next example. Okay, so you can see that this was a different perfect squares. Let's look at a different one. All right, so let's look at 15 x squared minus 27 x minus 6. Okay, so looking at this problem, we want to say, okay, is there anything that goes into all three of those numbers? I see they don't all have x's, but yes, 3 goes into all of them. So when I take out a 3, what am I left with? 5x squared minus 9x minus 2. Okay, so looking at this, and you might have some easier ones when you try it, but looking at this,
And Hollenkamp, please call
oops, okay, it appears that we are going to have to do the AC method. So this is good because this is a reminder of AC, or the magic number. So A times C is negative 10. Okay, so factors of negative 10. Negative 10, so that means one has to be positive, one has to be negative. So like negative 1 and 10, or 1 and negative 10. Hey, right away, I see they have to add up to negative 9. That's this right here. Okay, so I'm going to rewrite it. 3 times 5x squared minus 10x plus 1x minus 2. Okay, so remember, this is where we were rewriting. Now we group. So I'm going to take out a 5x. So I've got x minus 2. What can I take out of this? Oh, nothing. Okay, so plus 1, and I've got 1x minus 2. Okay, so final answer, remember we take these things are exactly the same, and we combine these. So my final answer is 3 times 5x plus 1 times x minus 2. And this is more complicated than perhaps what you'll see today in class, or tomorrow in class, but good reminder of AC method. Okay, so 3 I just want you to try, okay? You try. Okay, 1. 4x to the third plus 48x squared. 2. 2x squared minus 50. And 3. 3x squared minus 15x plus 18. Okay, that's it. Try these out. See what you can do. If nothing else, can you factor out a GCF? Okay, I want to see that work, and I'll take any questions you have tomorrow in class. Have a great night.